We're diving deep into the world of LLMs today. Specifically, we're going to be looking at this paper that you sent over. It's called Reinforce Plus Plus, a simple and efficient approach for aligning large language models. We're going to try to figure out, how this research is trying to make LLMs behave more like, helpful assistants and less like robots.
Yeah, so the paper really digs into this concept of reinforcement learning from human feedback, RLHF for short, which is, really one of the key ideas in aligning these large language models. Reinforce plus plus is sort of like the next step in how we train LLMs.
I think we can all relate to, feeling frustrated when technology doesn't quite understand what we want it to do. So what's the problem with LLMs that this idea of alignment is supposed to fix?
Well, LLMs are really good at generating human-like text, but what they produce isn't always, actually what humans want or something that we would consider ethically sound. Like, imagine if you had an LLM writing some marketing copy. It might write something amazing from a technical standpoint, but accidentally use like some really harmful stereotypes.
Right. So it's kind of like having a really talented intern,
Yeah.
but they might not quite get all the nuances of like human communication.
Yeah.
So RLHF is like training that intern.
Yeah, it is similar. It's basically a system of rewards where the LLM is encouraged to create text that that people actually like.
Okay, that makes sense. But I imagine there are some challenges when it comes to implementing this.
Definitely. One big challenge is that RLHF can be really computationally expensive. I mean, these models are huge and training them can take a lot of resources. The training can also be kind of unstable sometimes, which can lead to unexpected results.
That's where Reinforce Plus comes in. Like it's trying to address those limitations.
Exactly. It's aiming to make RLHF simpler, more stable, and also more efficient.
Those seem like really important goals. How exactly does it achieve all of that?
Well, the paper outlines three main roles for Reinforce Plus Blade. First, they wanted to make it simpler, so they actually built upon the Reinforce algorithm and made it easier to both understand and implement.
So it's kind of like making it more user-friendly in a way. So what about the stability part?
Well, they used some techniques to minimize the fluctuations in performance that you often see with other RLHF methods.
Oh, okay. So it's like they're making sure the system runs smoothly without breaking down. And then what's the third goal?
The third goal is efficiency. Basically, Reinforce Plus is able to do all of this while using less memory and processing power, which, could make LLMs more accessible to researchers and developers.
That's amazing. It's like a win-win-win situation. Can you maybe explain a bit more about how Reinforce Plus actually works?
Sure. So they utilize a number of techniques, including things like token level, KL penalty, PPO clip integration, mini batch updates, reward normalization, and advantage normalization.
Wow, that's a mouthful. Okay, so let's focus on one of those techniques for a second. The token level KL penalty. What is that exactly?
It's basically like a safeguard during the RLHF process. It stops the model from generating text that's too different from what it was initially trained on.
So make sure the model stays grounded while it's learning. That's interesting. I also noticed that the paper mentions testing Reinforce Plus Plus in different situations. Is that right?
Yeah, they wanted to see how versatile it was. So they tested it in both like general and mathematical domains. And what they found was that Reinforce Plus Plus was more stable than previous methods, and it was also more computationally efficient.
Okay, so you mentioned that Reinforce Plus Plus was more stable. What does that mean exactly?
Well, one thing they noticed was that it was really good at preventing what's called length hacking.
Length hacking, what is that?
Basically, it's when the model tries to kind of cheat the system by producing really long outputs, even if a shorter answer would make more sense.
So it's kind of like the model is learning to take shortcuts instead of actually understanding what it's supposed to be doing.
Yeah, you could think of it that way. And Reinforce Plus Plus helps to stop that from happening.
Interesting. And you also said that Reinforce Plus Plus was more efficient in terms of computation. What did they find there?
Well, they found that it used less memory and it took less time to train compared to other methods.
Oh, wow. So that's pretty significant, right?
Right.
That means it could potentially be used by a wider range of people.
Yeah, it could definitely have some interesting implications for how LLMs are developed and used in the future.
You mentioned a few other techniques that Reinforce Plus uses. Can you talk a little bit more about those?
Sure. So one of them is called PPO clip integration. And that's basically a way of stabilizing the training process. It prevents the model from making like really big updates that could throw off its learning.
Gotcha. That makes sense. Are there any other techniques that you think are worth highlighting?
Yeah. There's also something called mini batch updates. And that allows the model to learn from like smaller chunks of data instead of having to process everything all at
Oh,
once.
I see. So it's like breaking down the learning process into smaller, more manageable steps.
Exactly. It can make the training more efficient and also more stable.
That makes sense. And I think the last technique you mentioned was reward normalization.
Oh, right. Yeah. So reward normalization is all about making sure that the rewards that the model gets are consistent and balanced. This helps to prevent the model from getting like the wrong idea during training.
So it's like ensuring fairness in the feedback the model receives. This all seems really complicated, but I feel like you've explained it in a way that's actually pretty easy to understand. What was it about this research that stood out to you the most?
Um, I think the most interesting findings were definitely related to the stability and efficiency of reinforced plus plus way. Those are some pretty significant advancements.
Yeah, it sounds like Reinforce Plus Plus is making some real progress in figuring out how to make LLMs align better with what humans want.
I think so. It's an important step toward developing language models that are more reliable and predictable.
For sure. So where do you see this technology going from here? Like, what do you think the next step is?
Well, I think we need to do more research and development to really unlock the full potential of reinforced plus plus and other similar approaches.
Yeah, there's still a lot to learn and explore. This has been a really fascinating conversation. I feel like I have a much better understanding of this whole topic now.
I'm glad to hear that. It's been great talking to you about this.
So if any of our listeners want to go and, check out this research for themselves, where should they go?
The full paper is available on OpenRLHF's GitHub page.
Yeah, and we'll be sure to include a link in the show notes too. I'm always curious to kind of like peek into the future. So where do you think this kind of research might lead?
Well, it's always tough to predict for sure, but I do think there's a lot of potential here for developing LLMs that are even more advanced and reliable.
It sounds like Reinforce Plus Plus is a really promising step in the right direction. This has been a really great conversation. I feel like I've learned a lot about this topic.
Me too. It's been fun discussing this with you.
Awesome. And to all of our listeners out there, thanks for joining us on this deep dive into the world of LLMs and all the exciting stuff happening with Reinforce Plus Plus Post.
Until next time, keep exploring and keep learning.